chemistry, sometimes we see models of chemical reactions that look like this, where we have circles or some kind of shape that's supposed to represent atoms or elements and molecules. They might ask you questions like, did this reaction go to completion? How did the reactants form products? Draw the correct number of molecules of each substance that would be present in the reaction. Or even, which of the following best represents the molecules in the container after these elements have all reacted? If you've looked at questions like that before, or if you're just learning it for the first time and they've been confusing, let's break it down and do some practice representing the elements and compounds in chemical reactions as particles. First, let's take a look at a couple of completed models of chemical reactions. Here we see this is supposed to represent the reaction H2 plus N2 makes NH3. Let's see how that possibly works. Something I notice in the picture is a key. There is a key here showing what type of circle represents each element. So we see in this picture the dark blue represents N nitrogen and the light blue represents hydrogen. And I see in the reaction that hydrogen and nitrogen are going to combine together somehow to form molecules with one nitrogen and 3 hydrogens. So let's see, how did that happen? Remember, these big blue ones represent nitrogen and the little blue ones represent hydrogen. So to make one of these NH3 molecules, I have to combine 1 nitrogen with 3 hydrogens. Let's see how many of those that we can make. Here's another nitrogen, and I need to grab 3 hydrogens. Okay, here's another nitrogen. I gotta go around, but there's 3 hydrogens it can grab. And finally, this nitrogen up here can bond with these 3 hydrogens. So in total, when these elements chemically react with each other, the bonds between those atoms will break and new bonds will form to create the product NH3. I was able to make 1, 2, 3, 4 of those NH3 molecules. Let's see if that matches the model, matches the picture. It does. 1, 2, 3, and 4 NH3 molecules. So that's how this works. We have some kind of shape or color that represents each element, and you can see how they would recombine, rearrange to create the products. Let's look at another example. Oh, look at this reaction. This is the combustion of methane. So we have a little bit more complicated molecules with this methane. Methane has a carbon at the center and 4 hydrogens all around. It's reacting with oxygen molecules, so that's 2 oxygens bonded together. And it creates CO2 and water. Well, for every carbon, we need 2 oxygens to make a carbon dioxide. So let's use up all that carbon and see how many carbon dioxide molecules can we make. So I'm going to take this carbon and match it with these 2 carbon dioxides. I'm going to do the same thing with each carbon and see which ones are used and what's left over. Let's see. Okay, so I was able to make 4 carbon dioxide molecules. Let's see if that matches the picture. I have 1, 2, 3, and 4 of those carbon dioxide molecules. Now with what's left over, I need to make water molecules. We want to pay attention again to the ratio here. For water molecules, we have 1 oxygen for every 2 hydrogens. So I'll see what oxygens are left over and match all of those with 2 hydrogens. So that would make 1 water molecule. Let's go all the way around here and grab those other water molecules. Or sorry, those other hydrogens. These two will stick with this oxygen, those two there. You see how I'm just circling one oxygen and two hydrogens and seeing how many molecules can I make. Okay, it's kind of a mess, but let's go back and count. 1, 2, 3, 4, 5, 6, 7, and 8. I should have 8 water molecules in the products. Let's see. 1, 2, 3, 4, 5, 6, 7, and 8. Perfect. So now we see from start to finish how we can use a particle model to show how chemical reactions take place. The bonds break in the reactants and they rearrange to create products. Let's try drawing some from scratch. Here's the reaction between hydrogen molecules and chlorine molecules to form HCl, or hydrochloric acid. Let's see, how would this work? Well, the hydrochloric acid molecule is just one hydrogen and one chlorine. So that's pretty easy. I take one hydrogen and one chlorine. I can make 2 of these HCl molecules. Let's do it. So my hydrogen is yellow. Let's do 2 of those. And chlorine is red and it's bigger. You don't necessarily have to be size accurate, but sometimes it can be helpful, especially if you have complicated molecules with a lot of elements. So there we go. If I have 1 hydrogen molecule, 2 chlorine molecules, that can react to make 2 hydrogen chloride molecules. Next, let's make some more water molecules. This time we have just oxygen and hydrogen, no pesky methanes or carbons. Let's see how many of these water molecules can we make, and then let's draw them. So there's only 1 oxygen in the water molecule, so I'll start with those, and for every red oxygen, I will grab 2 hydrogens. So there, for every oxygen, I grab 2 hydrogens. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Whew, that's a lot of water molecules. Let's draw them. I'm going to start with just the oxygens. 1, 2, 3, 4, 5, 6, 7, and 8. 8 red circles to represent the oxygens, and I'll do just white ones like this outlined in black for hydrogens. There we have it. If we have this many hydrogen and oxygen molecules reacting, it will create 8 water molecules. Let's practice the same skill with a little bit more complicated chemical reactions. Can we represent these in the particle model? These chemical reactions are already balanced. They have coefficients that tell me the number of molecules to draw in each of my representations. So the first chemical reaction, I see we're reacting aluminum with oxygen to create aluminum oxide. There's a space for me to create a key. I need a different color or shape for each element. So aluminum, let's make green, and we'll go red for oxygen. Say oxygen will be represented by a red circle, and aluminum will be represented by a green circle. In the first box, I need to represent the first reactant, which is 4 aluminum atoms. So I'm just going to draw 4 separated aluminum atoms. I know that they're separated because the coefficient is 4. If this instead said Al with a subscript of 4, that would look different. That would look like 4 aluminums stuck together. So that's just something to keep in mind. A coefficient means 4 of this singular thing. A subscript means we're chemically bonded together. Next, let's draw the oxygens. This says I need to draw 3 of these things, 3 O2s. O2 means oxygen stuck to another oxygen. Those are chemically bonded. So there's O2, and I need to draw 3 of those. 1, 2, and 3. So I have 3 oxygen molecules represented by those red circles. Last, let's draw the product. I need 2 of this thing, 2 of these molecules that has aluminum and oxygen chemically bonded. The subscript means this is a molecule or compound. I'm not going to worry too much about accuracy of shape, but I know that whatever this thing looks like, it has 2 aluminums and 3 oxygens. Now in reality, this compound probably looks really different, and it does. But right now I'm just worried about representing what's going on in the reaction as particles. So I'm not worried about this being the correct shape. But I need 2 of these, so I'm going to draw another one. 2 green circles to represent the aluminums, and 3 red circles to represent the oxygens. And somehow these are all chemically bonded with each other. So here's the full reaction. I have the key showing that red means oxygen, green means aluminum. The first reactant is 4 aluminum atoms. The second reactant is 3 oxygen molecules, and that creates 2 aluminum oxide molecules or compounds. So it would look like this. Let's try another one. Remember, the first thing is the key. Now, maybe you don't have different colors you can use. You can use shapes. This time let's do lithium as a triangle and nitrogen as a circle. So the first reactant should be 6 lithiums. There's no subscript, so that means these 6 lithiums are not chemically bonded with each other. They're separated lithiums. So 1, 2, 3, 4, 5, and 6. And 2, this means bonded. And I guess I only need 1 of those. 1. Nitrogen bonded to another nitrogen. They're stuck together because of that subscript that tells me they're bonded. Now, what does this create? This creates 2 molecules, or 2 compounds, that have 3 lithiums and 1 nitrogen. So again, I'm not too worried about how this looks, just that I have each part of this compound represented. Because when you're on a quiz or a test, there might be molecules that you've never seen before. You don't know if they look accurate or not. This is not meant to be an accurate picture. It's just meant to give you an example and have you create some examples of how molecules and compounds can be represented as particles. Keep going and practicing this skill. I promise you it'll be worth it. You'll probably see some test questions like this. Have a great day. Keep doing chemistry.